So finally, the actual client-side application, right? That's what we're going to work on next, okay? We're using UWP because you're familiar, you've been working with it for a while. By the way, of course, UWP is now actually being, I hesitate to say deprecated, but replaced. There are some newer tools, WinUI 3 and so on, that are coming out. But you know, what you learned with this tool, just for the most part, carries over, right? So it's not, we haven't wasted your time by spending time with UWP. You know, it was really exciting. I'm kind of diverging here from my discussion when it came out, because it also supported one of my favorite things was Windows Mobile, right? Anyone ever have a Windows phone in the room? Oh, I got a bunch of them in my office. Actually, I preferred it. I loved that operating system. It was so simple. It wasn't near as convoluted and complex as Android. Much closer to iPhone that way, but without all the the very strict Apple aspect to it. It was just a nice little phone operating system. It's, to me, a real shame that it's died and gone to mobile phone heaven. Anyway, all right. So that was one of the neat things about UWP, is your application ran on that, as well as tablets and everything right up through to those big, huge monitors on the wall. Anyway, all right. So we're going to connect our UWP application to our database. Yeah, finally see our work pay off in some way. We need a connection string. Okay, that describes, you know, where the database server is, how we're going to connect to it, how we're going to authenticate, and everything else, right? It's basically describes the server and our credentials to be able to talk to the server, okay? And then we'll configure our app to pass the necessary credentials to the database. Guess what? It's pretty easy at this point, okay? And it doesn't, even if you publish your app up to a web server somewhere, it's really not that much more difficult, right? Then we'll look at creating two different styles, okay? 2-tier and 3-tier applications. Have you talked about that before? We're going to get into a little bit today, right? Basically, we'll have a code library and a full 3-tier, okay? And then the user interface is done with UWP, right? So generally the concept of 2-tier is you have the database, okay? And then you have your application. So we can do everything inside the actual front end, as it's sometimes referred to, okay? Now, in order to make it work, we do want to have some separation of concerns, right? So typically what we'll do is we'll create some sort of a data repository inside the actual application itself, okay? And the idea of any repository is it's like the curtain, right? The Wizard of Oz is behind the curtain and does all the magical things for us, and we don't really have to care about how, right? It just exposes some methods that we can call on. For example, say we're working with our company database, okay? Department employee, we might just have a get employees method that the repository provides for us. And we don't have to care how it goes and gets the employees, right? We just know that it will do it for us. If we want to add an employee, we have a method for that, right? So that's kind of what the repository is for. But then it can exist in the same project with the actual user interface itself, right? So the UI doesn't still talk directly to the database, it just talks to the repository. The repository is what deals with the actual database itself, okay? All right, now one of the things that we're going to get into talking about more and more, though, is the fact that when you work in C#, what kind of, I mean, you've worked with variables and objects and so on, so what kind of things are we going to work with in C# that kind of relate to our database tables? We kind of had a quick discussion about this. I showed you at the end of our PowerPoint where we talked about stored procedures, what the client-side code's eventually going to look like. So what do we call those things that we work with in C#? Maybe it's to describe an employee and all the fields that we have in an employee table. So when it comes to C#, we're dealing with a class, right? It's object-oriented, right? That's what C# is all about, object-oriented development, right? So we'll have a class to correspond to the table, right? So first, classes aren't exactly the same things as tables, okay? So what we end up needing is what is often referred to as an object relational map, okay? And there are tools that help automate that process for us, but we're going to start off doing it manually ourselves. We're going to take the data, manually create our objects with all the information coming from it, right? Okay, so a 2-tier is pretty simple. 3-tier, all we've really done here is we move that business layer, that repository, okay? We move it out of the actual project itself. So we have a separate project, okay, which often then we can actually compile into just a DLL. You've done that before in your work with C#, right? So then the user interface can just have a reference to the DLL, which is totally separate then, giving that business or data layer in between the database and the UI, right? So that just further separates the UI from the database, but really it's more a matter of where the files are sitting, right? Then really, truly, you almost had the same separation with the 2-tier, but you know, why go to 3-tier? Well, it maximizes, right, that separation of concerns, okay? Makes the code more modular, which, you know, in a really large enterprise application situation, this does make a big difference because you might have one whole team of developers working on that middle layer, okay, the data layer, right? And you know, maintaining it, right, as opposed to another team is working on the UI. So it allows, with that separation of concern, it allows more scalability as well, right? Because you might decide, you know what, our app is slowing down because we have so many users, we need to beef up the server support for that middle layer, or maybe the back end, right? So each is kind of living separately, and you can scale each layer independently, okay? It helps for reusability as well because there's such a great separation of concerns. Concurrent development, as I said, different teams can be working concurrently on different parts of the, or layers of the 3-tier application and so on, okay? And there's some security advantages as well, right? So lots of reasons why you might eventually go with 3-tier, but you know what? A lot of the time, initially, because it's more convenient, we'll often start with a 2-tier, and you can always just break it out later on. It's very easy to go from a 2-tier to a 3-tier at a point down the road. Okay, so whether it's contained in a 2-tier or a 3-tier, we're always going to have sort of that business layer or data layer, usually done with a repository design pattern. If you look it up, you'll find that's what a repository is. It's a pattern, a roadmap, so to speak, on how you might put it together. We've already talked about the essential thing is it just exposes simple methods, and we don't have to care how it's going to do it. By the way, one of the advantages of that as well, right, is that say you switch from SQL Server to a different database system. Well, all you have to do is modify the repository because that's all happening behind the curtain. So how it connects to it, how it executes commands, we don't have to care. We just have a repository presenting very simple little methods. And the whole front end of the program, okay, we'll just call those methods, and that never changes, right? So yeah, you can easily swap out, go to a different repository and work with a different database system altogether, okay? So, you know, we're going to do an example. We'll talk about using our vet office type database, our pets and species and so on, okay, just in our discussion. And then we'll do an example application as well in a few minutes, right? But just for the discussion, I decided not to use this because it's so similar to the lab work, but it's still in my PowerPoint. But, you know, it's just the concept we're talking about. The idea is we have classes, right? And they correspond to the actual table. So, you know, what we end up having is classes to represent those table objects and the different records and so on. So, you know, the data types are not the same. We don't have varchar, right? No such thing in C# as varchar. All we have is, what would be the one to correspond? String. Yeah, we have strings, right? That's it. Yeah. You know, we have date times, we have strings. We do have different types of numerics, integer, int64, and so on. Okay, int64 is the one you'd probably use for a big int, for example, in SQL Server and so on. But, you know, there's a way to figure out, you know, what ones you're going to use as you go back and forth between the objects and the relational database system, right? Okay. By the way, a note there about the style of writing these classes. You don't see, like, these are the simple way of presenting a property, right? With a getter, setter like that. There's no code. You've done a lot of work in your object-oriented programming course, you know, going into the setter, adding some logic of one type or another, saying, oh, no, we're not going to, allow that, or we're going to make modifications to it as the value is set, and so on and so forth. These are what we call POCO, or plain old CLR objects. Very rarely, in fact, virtually never, with an object relational mapping system, do we do that kind of coding inside the class itself. For one reason, okay, we leave that up to other parts of the application to do that same kind of logical enforcement of whatever the rule is that you're trying to do, right? We put that somewhere else so that the POCO object itself can just be a vessel for carrying that simple data from the database to the app and back and forth, right? So you'll see it's a totally different style from the kind of programming you've been doing in your object-oriented in that aspect. Okay. So as I said, the repository class will represent database actions. It'll give us methods, okay, that we can call. 3 main jobs, okay. It has to look after talking to the database, make and maintain the connection to the database when it's needed, perform queries against the database, okay, and of course, we can do queries in a number of ways. We can write our SQL commands, select star from, for example, insert into, and so on and so forth, and we can execute those directly. Or, as we had talked about or hinted earlier on, stored procedures are a wonderful way to interact with the database. It's actually far more controlled, right? And it's also more secure, okay? If you give carte blanche aspect to a client to write any kind of SQL and execute it, well, you've heard of SQL injection attacks, right? It's very easy for a client application to allow that, and that's one way to avoid it, is to use stored procedures. But in any case, queries execute against the database. Second job. Third one is to actually map the database data, okay, from the database tables into the objects that we're working with in C#, okay? And that's where we'll often work with an object relational mapping system. There's many of them out there. You'll have experience by the time you're done here. We don't have time to look at any framework this term, but we'll be using that exclusively almost, okay, or extensively, I should say, in the next 2 terms. We'll be working with Entity Framework, right? But Dapper is the one we're going to introduce today. We're going to play around with Dapper, and it is very dapper. It's a suitable name, okay? All right, we'll talk more about that in a few minutes. For the connection, we basically need some object that implements this overall interface. I for interface, DB connection, okay? Now, one of the ones that inherits from that is the SQL connection object, okay? It inherits from the DB connection, okay? So we'll have an SQL connection object. It takes a connection string, creates a connection to the database that then we can use to do all the work we need to do, whether we're directly executing SQL commands as text strings or calling on stored procedures, whatever, right? Now I've got a link here in the PowerPoint on documentation from Microsoft on the connection string. They aren't that bad. At first glance, it can be pretty intimidating trying to put some of these connection strings together, but for the most part, they really aren't too bad. When you get into named instances versus default instances, there's little changes there. SQL Server Express, trust certificates, and so on. So there's lots of documentation available. And of course, these days, you can ask your favorite AI to help you write a connection string to the database as well. That's just the reality of it, right? Enabling encryption or not, and so on and so forth. Okay, so we'll just help you out at first with getting some basic connection strings that'll probably do the job for you. By the way, when I was working in my office this morning, I almost forgot that I needed a different connection string because my SQL Server on my laptop is set up differently. But we can talk about that as time goes on. Final note there. You don't want to code the connection string right into your classes, right? It should be in one place, okay? Often in a secure place that isn't easy for hackers to find it, right? But the most important thing is to have it in one obvious spot so that if you have to update it, you can do it in one location. If you have it spread out, okay, in 10 different spots in code, then, what if you, in a search and replace, you miss one, or things like that, if you need to update your connection string. So, it's a good example of, that's one of the design principles. Can't think of the name of it off the top of my head right now. Anyway, don't repeat yourself. Don't have it in more than one place in code. All right. So we will be looking at a couple different ORMs over time. As I said, we'll be looking at Entity Framework Core and Dapper. So here's a bit of a comparison if you're kind of curious, right? I'm always curious when something new is introduced. So since we'll be working with both, here's kind of a breakdown here. The type of ORM, Dapper is considered a micro, itty bitty little wee fellow, okay? Object relational mapping system. Nowhere near as full featured, nowhere near as powerful as Entity Framework, right? But, okay, it works with raw SQL, and of course included in that as well is the ability to call a stored procedure, because that's still, we're just saying the name of the procedure and any parameters we want for it and so on. Dapper actually is faster. You might say, well, why don't we always use Dapper? Well, it's only marginally faster, and because there's a lot more overhead to Entity Framework. But Entity Framework, as I said, is much more full-featured, much more powerful. It has built-in change tracking. It has support for migrations, right? And that's where we're going to spend a lot of time next term learning how to use migrations. So, yeah, you could go in to the database and update, the design of a table, add a new column, and so on. But with Entity Framework Core, you can do that, or you can go into the class. Say you have your employee class with the company database. You decide you need a new property in the class. We just add it to the class, and you tell Entity Framework to go modify the design of the database to match, right? Those are migrations. And then you can add more and more migrations, okay, and go forward through them, reverse back through them, and so on, go back to an earlier design and things like that. So it supports much more complex models. Very good for rapid development, Entity Framework, okay? But, Dapper has its place, right? It is a little bit faster. Very good for read-heavy, performance-critical applications, okay? Nothing wrong with Dapper. Just be aware that it's much more limited than Entity Framework. All right. So we're going to install the Dapper extension, same way you normally would in any NuGet package. You've used the NuGet package manager before, right? Good. I'd like to see nods around the room. That's good. So that's how we'll add the Dapper package as well. And we'll just start using it. We'll do that in our demo in just a few minutes. All right. So in terms of the actions, the methods, okay, what do we need for dealing with our data, okay? Well, guess what? Our standard stored procedures pretty much mimic the normal actions that a client application usually needs. Give me all the records. Give me that one record identified by the most obvious thing as the primary key, right? There we go. Add a new record, okay? Update an existing record, remove a record, insert, update, delete, right? Those are the most common actions that any client application will use. You think about it, you sit down, yeah, sure, we know we can do a bulk insert or update hundreds of records, okay, at the same time. But that's not how an application normally works. Normally you bring up the record for a given order or a customer or whatever it is, and you make a change and save that change to the one record you're working with, right? Okay. So, as I say here, if you've done all that work and created standard stored procedures, then we can work through them without exposing details of the database schema, without exposing ourselves to possible SQL injection attacks and so on and so forth, right? Okay, and what we can do is when our methods are complete in our repository class or however you're approaching it, you can actually, if it's in a separate project, we can just build that library into a DLL file and then just use it from multiple. That's another advantage of a 3-tier, is we can create multiple user interfaces that all just connect to the same DLL, right? And that's another possibility you can do by going to the full 3-tier approach to development. We will do a 3-tier, actually in your final project, you're going to do a 3-tier application. Okay. So this is the kind, we've looked at this sort of thing before, okay? So once we have our connection object, which is called DB here in this code sample, we can just use the various commands in it, right? Query, first or default. By the way, you're familiar with asynchronous operations? You've done some work with that? Maybe not. Oh, okay. All right, well, we'll be focusing mostly on asynchronous. What that means is, if you, a synchronous operation, say you give a command to the database, execute this query and return our all 100 million thousand rows of data. It can take a few moments to do that. In a synchronous operation, your code in your application sits there and waits. Nothing will happen. It waits until the response comes back from the database, right? And that's okay, because really, until you have the data, maybe there's nothing else to do. So why not let it sit and wait? Trouble is, okay, that holds up everything else from running, right? So an asynchronous operation will basically say, hey, tell you what, I've asked for it, but in the meantime, I can update the screen, okay? I can do something else. I can be useful in other ways. And then an asynchronous operation will let the app know, we're done. We're ready. Ding! The microwave went bing, right? So we're ready to take it out and start working with it. So it doesn't, it's usually more efficient, especially. Truth is, it makes very little difference if there's only one user. But if there's, 50 users all working in the system, that connection to the database is also held up. So everyone else's work is held up in a synchronous operation. But with asynchronous, they can all carry on and be updating their record on the screen or doing what else they want to do. And they aren't held up by your operation waiting for it to come back from the database. So as a general rule, especially for multiple users, we definitely want to start moving towards asynchronous. It used to be a real pain in the rear end because you actually had to, basically kick off the operation and then have a listener sitting there listening to microwave to go ding, right? To let the app know. Well, they've taken away all that complexity for us. All we do is we say await, as it shows here. Await, okay? We define it as an async method, and then we just say await, and then it's automatic, okay? It does all that low-level plumbing for us now that we used to have to do manually, and just takes care of listening for the microwave to go ding and then letting us know that we can carry on with this code, not holding up any other code from executing in the meantime, right? There we go. So the other point of this slide here, I'm showing that in the SQL string, as soon as possible, I want to get away from SQL strings, but they are useful in certain circumstances, right? We can actually just have, because we're using that $sign at the beginning, okay, basically it's an inline parameter almost, right? That ampersand around the tag, and so we can just pass that, okay, as a parameter to the SQL string in this nice, convenient syntax that we have available here. Okay, of course the name has to match, otherwise you'll have a problem using this approach. All right, so that's just a quick example then of executing a command in the database using our database connection. All right, so, final thing, we'll see this. Our client application, of course, has to authenticate to the database. Right now, you authenticate, right? When you open SQL Server Management Studio, you have to authenticate. You have to go through that. Now, mind you, it's pretty simple because we have basically enterprise authentication set up, okay? And that's good, but we have to tell in your UWP application in the capabilities that we're going to use enterprise authentication. Now, of course, this only works because we're working on the same machine that the database server's on, right? We're logged into the machine, we're logged into the app, basically it's implied, so we can log into the database with our own credentials that we're logged into the system. That's what enterprise authentication is about. It's not that Captain Kirk is coming down and typing a password for us here, right? That's not the kind of enterprise we're talking about. No, it's just recognizing the current logged in user is all that it's really doing. Okay, we'll look and see how we get that set up in a minute, right? So, where do we put that darn connection string? Well, there are good places and better places, okay? And a very good place is good enough for now is in the app object itself. You've been working with UWP projects enough now, you're familiar with the app object. Have you been using the app object very much? Every once in a while for something, okay? Well, for one thing, it's kind of a global place where a lot of the features of the app are set up. It's also where if you're going to have your own sort of styles for your XAML code and things like that, usually we define them in the app object. One reason why it's a great place for stuff like that is it is by definition a singleton. Is that a new word for you? Have you talked about singletons? It's technically a design pattern again. Guess what? Our term together next term? The course is called design patterns. Anyway, so the singleton design pattern means, okay, you only ever have one object of this class in your application. You're safe that way. There's no confusion, right? There will never be more than one app object, right? So it's a great place to put something like this, that, hey, we want this connection string available everywhere. We only want one copy of it to exist in the application. So we'll put in the app object itself. As a singleton, we're guaranteed to be safe then, that way, right? So inside the app itself, then, this is a good approach. We'll create a private static string to hold it, but then we'll expose it as a public static string, right? So that it's available throughout the entire application. If we left it only as private, that would be a complication getting to it. But by making a public version of it, we can actually get the database connection there. So we kind of skipped over all the documentation. I said go look at it on your own for how to put a connection string together. But basically this is pretty much the same as what we're going to use, right? Data source we define. The first thing you pass is the server. /SQL Express. Well, hang on one second. Somewhere in here, yeah, here is our, oh darn. I want to get this up on the screen. It won't let me move it until I log in. I'm going to cheat. You're familiar with this dialog box, right? When you log in right now, okay, make sure you trust the server's okay, but look at that. This is the actual computer's ID, S310020 /SQL Express. So what we have here, this is a named instance. It has the name SQL Express. It's on a computer, so we have the computer / the name of the instance. Well, in case you haven't tried it before, you don't need the full name. You can just put dot. Dot is just a short form for whatever the darn name of this computer is, right? So that's why our connection string works fine with just ./. It's the computer name, okay? It's sort of an alias for it, or a short form for whatever computer you're on, /SQL Express, okay? Now, if you're on, like, as I said, I had to change the connection string when I was using brought up one of my sample apps in my office this morning. Well, my database isn't a named instance. Okay, it actually just is local. So that's would be my connection would just be in round brackets local, okay, instead of the whole ./SQL Express. So, it can change. That's all I'm emphasizing. So maybe when you get home to your computer, depending on how you installed SQL Express, trick is look how you log into it, right, into Management Studio, and that'll give you a pretty good idea how to log in or create your connection string. After that, initial catalog is the name of the database, right? Integrated security equals true. That just means we're going to use the built-in security system of Windows. You're logged in, and away we go, right? The other choice is you can actually say username equals and password equals, right? Which is a very dangerous thing to have inside of a string like that in the app. But hey, there are times when that's where you might put up your connection string, and eventually if you're publishing this to a server somewhere, you'd probably in something like a key vault or something like that. But for now, this is good enough for us. Okay, all right, so displaying data on the page, okay, basically, we'll actually new up a repository object, okay, passing the connection string from our app, okay, and then I'll create an instance of the connection that we need. And the repository makes the connection. The repository has exposed the methods that we need to get our data, and away we go. So we might have methods we saw just like this, get pets by name, right? And then that will give us the data to show on the screen itself. So that's basically it. Let's get into a demo, okay? So, some important concepts there in terms of UI design. Validating user input, okay? You want to make sure that we make sure there's valid input. Now a bit of a twist on that. Sometimes the validation rules are enforced by the database. If you put them in your own code, it's not a bad thing, right? Because why wait for the database to tell you about the error if it's something obvious, okay? So there's nothing wrong with validating input in code as well. Just know it'll be checked again when it gets to the database in many cases, right? Always, anytime you're calling for a method that's going to talk to the database, always put it in a try-catch. Yes, there are other approaches that are valid as well, but at this point, I'm going to strongly encourage you to use our try-catch structure, right? Because there always can be a problem connecting to the database. Maybe you've lost the connection. Maybe it is on a separate machine. The network went down, or the server went down, right? Nothing to do with any problem with the database. It's just you can't talk to it. Or maybe there's an actual issue inside the database, or any one of a number of other reasons why there will be an exception raised, right? And so our try-catch will be the way to go, right? Verifying that values exist are not null and so on, okay? And you want to always give some feedback to the user, okay? So you'll see we'll eventually set up, even in our next demo, a mechanism to take the feedback coming from the database and make sure it gets propagated through and displayed to the user as well. Okay, so we have our own chance to tell them about issues, but we want to make sure if the database has something to say, the user has a chance to see that in addition. All right. Oh, the final note here. This might come up when you do a 3-tier. Your class library might not get built, so this is just thrown in because it's a common little boo-boo. If your build of the class library gets skipped because you're focusing in the project for the user interface itself, then you can fix it by following these instructions here. Just right-click the Solution Explorer, go to the Configuration Manager, and make sure all the settings for building are necessary, right? Because you don't deploy the class library, that's just a DLL, right? You will deploy the user interface itself. Okay, well that finishes our discussion for now.